Everybody, good morning. Welcome to Montreal. I'm here to give a presentation on the Danish Meteorological Institute's activities on sea surface temperature and combined sea surface and sea ice surface temperature products for the Copernicus Marine Service, which is something we've been doing for a while now, and also for the Copernicus Climate Change Service, which is something new I'm gonna briefly mention today, and there's a dedicated presentation tomorrow. This is a combined effort from many of us, some of us here, Pia, myself, Jakob, of course, who unfortunately could not make it, and a team of colleagues back at DMI. So just briefly, Andrea Pisano gave a very nice overview talk about the Copernicus Marine Service and more specifically the Sea Surface Temperature Thematic Assembly Center. My presentation also includes some of the products we release for the Sea Ice Thematic Assembly Center. And if you could, you would identify there are two different logos up there. So we provide our products to two different TAACs, as we call them. The SST TAAC, as Andrea mentioned, we provide regional products for the Baltic Sea, and you can see some examples here on the left-hand side. So we provide level 3 super-collated products daily at near real time, but also multi-year. And we also provide level 4 SST products for the North Sea Baltic Sea, also as near real time, but also as multi-year products. And we also provide similar services for the sea ice TAAC on the Arctic Ocean, and that is a combined sea surface temperature and sea ice surface temperature product, level 4 and level 3S. There's more information on this website. You can find all the products there, and also to mention all the products are available on the GRIST catalog. And you can easily find them if you just click on the Baltic Sea subdomain, which appears on the map on the left, then all the products pop up there. So just a brief overview with code names, and maybe this is a bit of a boring slide, but just an idea of how you can identify our products. We have here, I'm talking only about the Baltic SST products. And they are two near real-time products, the level 4, that's available from 2016 onwards at 0.02 degrees. And we have a similar L3S product that we released from 2019 onwards, and they are available every day. And we also have another near real-time product available every day since 2022, which is an hourly diurnal product that's recently new. That's recent, actually, sorry, new. And we also have a set of the multi-year products, both level 4 and level 3S from 1982 ongoing. And they are also at a 0.02 degrees grid spacing. They have regular temporal extensions. And we use ESA CCI and Copernicus C3S input data for SST. And these products will be reprocessed or are being reprocessed now in 2024 with the latest version of the ESA CCI data, version 3, and they will be released on the November entry into service. And particularly for the level 4 multi-year product, there's also a dedicated paper about that, but of the previous version, not the version of this year. This is an example representation of the processing chain where we get our input data, and we also get sea ice concentration fields for the Northern Baltic. And then we pre-process to level 3. We do some bias correction using reference sensors. Then we do optimal interpolation. And in the end, we release the optimal interpolated SST and the associated uncertainties. And moving on to a similar slide for the Arctic, combined sea surface temperature and sea ice surface temperature products. We've got a near real-time daily combined this SST-IST product at 0.05 degrees grid spacing, available from 2019 onwards. And then we've got the famous multi-year reanalysis that Pia has grand engineered. And that's a level 4 product and also an associated level 3 super-collated product from 1982. to 2023 now. It also undergoes regular temporal updates. We use ECCC and Copernicus C3S input data for SST, and the ASTI data that was also mentioned earlier from Stefan for the IST. There's also an associated publication for the reanalysis product. And this is a typical flow diagram of the production chain for this. And again, we have input data for SST and IST. We do a bit more on the sea ice concentration because that's much more relevant for the Arctic. And then we pre-process to level 3S. And finally, we apply the optimal interpolation and we release the level 4 product and the associated uncertainty. And one of the things we constantly do is validation. So we validate both the near real-time products for the Baltic. We also validate the multi-year products for the Baltic and the same for the Arctic. And you have here some example validation metrics. Just a brief skim through them. When we are looking at drifting buoys, which are relatively few in the Baltic, we get biases in the order of 0 or 0.1 degrees and standard deviations in the order of 0.3 or 0.4 degrees for the near real time and the multi-year respectively. Our diurnal product that has been released in 2022 is performing a bit worse in terms of standard deviation, and we are on the lookout to improve this product. It has been a very first approach when releasing it. And similarly, we do validation both on the near real-time Arctic, so we are looking at SST metrics with biases in the order of 0.1 and standard deviations in the order of 0.5. And when we validate the ice surface temperatures, that's much more complicated because we usually do that using 2-meter air temperatures, as skin temperatures over the ice are not available in situ, and our metrics are in the order of 2.8 degrees in the mean bias and then 3.4 degrees in the standard deviation. But this is kind of expected because of the difference between 2-meter temperatures and skin. And then we also do the validation on the multi-year product separately for the SST and the IST. And here are some, when we look at drifting buoys over the 30-year period, we get a mean bias on the SST and 0.5 degree standard deviation. And then we validate the ice surface temperature using different available in situ. And when we look at the real ice surface temperatures of the ice bridge flight campaigns, then we see that we get much better metrics compared to the actual drifting buoys, ice buoys that are 2-meter air temperatures. And then moving on to the ocean monitoring indicators, these are some metrics we provide for the Copernicus Marine Service, and we do that both for the Baltic products and the Arctic products. This is an example of the annual mean sea surface temperature anomaly, including 2023. And it's relative to the climatology between 1991 and 2020. We just recently updated these metrics based on the Ocean State Report that Andrea mentioned earlier. And what you see here is that we get actually quite large warming over the entire domain of interest, more or less. The average anomaly for combining the North Sea and the Baltic Sea Basin is almost 0.5 degrees. When we look at the Baltic Sea Basin, only the anomaly is much higher. This is an example of one of the monitoring indicators. We also provide monthly mean and 1-year moving anomalies from 1982 up to today, or up to when the data are available, also relative to the 91-2020 climatology. And you can see the 1-year moving mean in blue for the combined North Sea, Baltic Sea, and only Baltic Sea Basin. And the cyan lines are the monthly mean anomalies. And what we see here is that we have an average warming trend of 0.029 degrees per year for the combination of basins, which goes up to 0.038 for only the Baltic. That means for the period of consideration, we are looking at a warming of 1.2 to 1.6 degrees Celsius. And similarly, we also have a trend. It's just a 2D map of where the trends are, significant trends, how they look. And as you see, we are looking at trends upwards of 0.5 degrees pretty much all over the basin. both basins, and we release the same indicators for the Arctic Ocean, and just some metrics here. You see the annual mean surface temperature anomaly, including for 2023, looking at 1.5 to 2 degrees and more in pretty much most of the area. There's some cooler anomalies right here of Greenland, but the average anomaly is 1.7 degrees. And then when we look at the trends, again, we see very significant trends in large parts of the Arctic Ocean, the Kara Sea, the Chukchi Sea, the East Siberian Sea. And when we look at the combined trend, it's 0.04 degrees. And that represents a warming of 4.37 degrees in the period of 1982 to 2023. And a similar plot for the monthly mean in cyan and the one-year moving mean anomaly in blue relative to the 1991 to 2020 climatology. And again, we are looking here at the trend of 0.1 degrees. And just as a warm-up, as I mentioned earlier, we are also releasing, due to an activation clause related to contracting and Brexit, we are releasing this year a new Copernicus climate change service product. It's a global combined sea surface and ice surface temperature at 0.05 degrees grid spacing. It's a combined SST 20 centimeters from the CCI version 3 data and IST skin CDR. The IST component comes from ASTI, and it will be released by September 2024 for the CDR period, which is 1982 to 2022. And then by the end of the year, we will extend for 23 and 24. And there's a dedicated presentation for that tomorrow. And this is an example of how the product will look, covering, this is from January 2015. So we are covering open water, marginalized zone, and sea ice. And finally, we also have a global product at the same resolution available near real time. It's not part of the Copernicus or the C3S umbrella, but we make it in-house. And right now we only disseminate it through PO.DAAC and the cloud services now. And we are, of course, looking at improving that and having it used by some more users, doing some better validation. And that's all for me now. Thank you very much for your attention and questions.
Thanks, Ioanna. Any questions? No, you do need the mic because otherwise people...
Sorry, yeah, IceBridge is a NASA campaign on flights with a radiometer on the airplane that monitor the sea ice and the ice over the Arctic. And they also include Greenland, and they fly out in different paths. I don't know if they still do that, but we've got data for a period of time until 2019, I think, or something, right? 19, yeah. Sorry for not being explicit. Yeah. Okay. Sure. We can talk offline, and also Pia knows a lot about the data.
Any more questions? Okay, thanks, Ioanna.
Thank you.
So now we move to the next presentation, Misako Kachi, giving us the report from JAXA.
Good morning, I'm Misako Kachi from JAXA, Earth Observation Research Center. Here's my colleague is who they contributed to make this presentation. So the JAXA is the space agency in Japan, and we are operating the several currently the 7 satellite mission, including the collaborating mission with the ESA or NASA, and the Oh, sorry. This is the JAXA, Japanese the Earth observation satellite and sensor list, and we are also included the JMA, Japan Meteorological Agency's Himawari geostationary satellite in here for the kind of reference. But we also collaborate with JMA to provide the SST Himawari SST data from the JAXA server. And currently we are operating the 7. Is the one is the it's the Aerospace. So this is the synthetic capital radar for land observation, and the SGRI the IR SST is provided from the SGRI GCOM-C. And also recently we launched the Earth Care mission. This is a joint mission with the ESA, but this is also the Aerosol and the Aerosol Cloud mission. And then we operating the GPM with NASA. We also providing the GMI microwave SST from GPM and also the AMSAT 2 in GCOM-W. And we are preparing for the launch of the GOSAT GW AMSAT 3 in this Japanese fiscal year. Okay, here's the list of the GRIS dataset, and in providing the GDS 2.0 format. All those data is provided from the JAXA's GRIS server, and also the Himawari SST data is provided through the JAXA's Himawari monitor website, along with the other geophysical parameters produced from Himawari data. And the red color indicating the several updates from the last year's my report. And we updated the SST of the AMSAT 2 and the minor version updated 4.11, and also the GMI it's a tentative post. And also the Himawari 9 data is also modified for the some of the level 3 data. And here is just the brief status for the update from the last year. Our data, as I explained, our data set is available from the JAXA's the website. What's happened? Where I'm not. Sorry, I think. Right. Okay, here now. Sorry for that. Yeah, I shouldn't push you in the longer time. Okay, I see. So here the server URL. And now we are working for the responses to the RGTS task sharing requirement to connect to GRIS portal via the open search to the JAXA's the server to get the data. In the last year, and we investigated the technical the point of view for that, and I think that we are currently working on how to there is several technical issues within JAXA and to doing this at this moment, and we are now working with my colleague to how system to be, and maybe we will working for the system design this fiscal year, and developing something in the next year, and also for the GRIS catalog things, and we are also talking with the GPO and the Jean-François for about how to input this data, JAXA's data to the GRIS catalog, and due to some of the unexpected the tasks in my job, and I cannot do that before this GRIS meeting. But I'm and my colleague is working. Will work to make input to the GRIS catalog for the JAXA's data, and then you can easily find them in the GRIS catalog in near future. And also they are, we don't have much updated from the GCOM-C SGS. It's operating in orbit and in healthy condition, and we continue to provide the data. And Himawari data, it's some related poster by the Yukio in the poster session. And we also had updated the level 3 daily and monthly product to version 2.11 in April this year. This is the objective is to provide at first that we only provided the daily product, the daily minimum SST. However, there is some requirement to do that to providing the mean SST and also the along with the daily minimum. So then we decided to distribute the daily minimum, daily maximum, and the daily mean SST for the Himawari data from the version 2.11. And we reprocessed all the Himawari past data to making this one. And so then we already also change the level 3 monthly data product using this level 2 mean SST data. Okay, and also for the GMI, GPM GMI, now we distributed the GMI 10 gigahertz SST product from the server. But in the last of November, there's the orbit race of the GPM satellite to extend their mission life, and to corresponding to that the changes, and we tentatively stopped the distribution of the GMI SST at present. And also for the AMSA2 GCOMDAP, I have my colleague, the Eri Yoshizawa, will make the poster presentation regarding the SST comparison with the in Arctic region, and also I will also make a poster for the radio frequency interferences in C-band. So if you're interested, please visit our posters. And for the AMSA2, we updated version 4.11 in April. This is just to handle the ancillary SST data, MGSST, in a higher SST condition. So last year we found that the SST in more than 35 degrees Celsius in MGSST. This is the unexpected to us. So that has stopped our system processing. So we needed to change before this summer come. And we now, if we can receive the SST more than 35 degrees, it's okay for us at present. And also for the CI sickness, summarized sickness product is released from our server from the March 2024. This is not a SST product, but maybe in Arctic people who in Arctic SST researchers may be interested in, and I will explain this a little bit later. And also the development of the enhanced brightness temperature product for cryosphere studies, and we recently distributed the test product version 2. And this I will also explain this later, but we are planning to extend this one to the SST higher enhanced SST product for the microwave AMSA2. And also for the GOSAT GW AMSA3 has to be launched in this fiscal year. It is quite really likely to be launched in late this year or early next year. And we are now ready. We are preparing for the launch. And early data access will be available to the selected principal investigator selected by the research announcement, and also the partner agencies. And the AMSA3 in GDS 2.0 format. So we will be available from the JAXA server after the public data release. So that will be the planning in 1 year after the launch. And also the fourth JAXA's observation research announcement could be the selected PI. It will be issued in really soon, and this is maybe the last chance to access to the early data of the AMSA3, and if you propose for this research announcement. Okay, so here's the slide, quite short introduction for the CI thickness product of the AMSA2. So this is the estimated by the empirical equation between the 36 polarization and the for the ratio of CS thickness. And my colleague Nakata-san is working for that and derive an empirical calculation assumption the CS thickness. And here's the example. Oh, sorry. Again. Wow. I just pushed once or something. Okay, right. And here the CS thickness for the and the CS top is provided, and we also validated these data using the MODIS seen now that the CS thickness area, and had quite a nice accuracy for that. This data is provided distributed from the JAXA research data server. And also we are working for the development of the enhanced resolution ARMSAT2. And as you know, the microwave, the weakness of the microwave product is its coarse spatial resolution. And we are working for that and for the ARMSAT2 in the enhanced resolution. Then using the RCIR method of the Long et al. And for this data set is here's the example of the original 89 gigahertz brightness temperature vertical polarization. So it's plotted in a 5 kilometer grid point. It's a Gaussian with the Gaussian interpolation. So this is the almost original footprint size in 89 gigahertz channel, and with the enhanced resolution in 2.5 kilometer grid, and you can see more clear the structure of the ice in Arctic region, and also but you still see that there's a kind of these are the scan line. This is the kind of the stripe noise, and then it caused by in amplitude the observation for the 89 gigahertz channel. And this we also then removed in the version 2. We also removed this the stripe noise. And then it's now we this the brightness temperature can be produced. And with this product is currently tested by the collaborative researchers. And also this is only for the cryosphere area, and also the brightness temperature channel is limited at the 36 or the 18 gigahertz channel. However, we are now planning to extend the method to the 6.9 gigahertz and the 10 gigahertz channel to have the test of the SSD retrieval to using this method. And also, this is the last slide. Is goes to the status, but I think that I don't say much because we have not so much the update from the last year, but we are just preparing for the launch and for the Japanese fiscal year of 2024, and we have the major improvement in an additional high frequency channel, and also the additional 10-point gigahertz channel. With the improved NVDT, and so now we had we can have retrieve the SSD more robust condition, and even using the 10 gigahertz brightness temperature. Okay, that's all. Thank you very much.
Thank you, Misako. Any questions? Okay, so I think we move on. The next presentation is Danielle Carpenter giving us a report from NAVOCEANO.
Good morning, everyone. Danielle Carpenter. I am the Satellite Technical Lead for the Remote Sensing Branch at the Naval Oceanographic Office. Bruce McKenzie sends his regards. Last year, he did take a promotion to a different division, but he did want me to tell everyone hi. So I'll keep it pretty short and sweet for this one. So our status update from the last year. We've added NOAA 20 and NOAA 21 VIIRs to the data that we provide to the PO.DAAC. As far as data that we acquire to go into our assimilation for delivery to FINMOC for the model, nothing has changed in the last year there. Also, the METOP B and C Global 1 kilometer product is available. If anyone is interested, you can shoot us an email. It'll be at the end of the presentation. So updates, we have a couple different products that are ready for model ingest. FINMOC is just not ready to fully ingest it yet, so we're just waiting on that step. And as previously mentioned, we have updates to all of the files that we deliver to the PO.DAAC that gets disseminated out to whoever needs it. So for future work, we are just awaiting the availability of MTG I1 as well as WSFM data. And we are also awaiting the GOES-U launch that's coming up in 2 weeks. We also have quite a 5-year plan of satellites that we'll be looking to ingest in the future. That's just not mentioned here. That's all I have. So quick 30 seconds.
Thank you. Any questions? Okay, so we'll move on. The next presentation is Ed Armstrong, giving us the NASA JPL updates.
Hey everyone, good morning. I'm Ed Armstrong. I'm from the NASA Jet Propulsion Laboratory where I work in the physical oceanography DAAC. That's one of the 12 NASA Earth science data centers, and we're the ones that specialize in all the physical oceanography measurements, including temperature. And of course, I'm here talking, but I'm representing a large team of 20 plus people that all contribute and help make things run smoothly in the PO.DAAC. I wanted to kind of start off on a little bit of a sad note, but to inform you that Wen-Hao Lee, who worked with many of you in this room and really was a foundational piece in our PO.DAAC data engineering team, was unfortunately laid off about a month or two ago, kind of swept up in some of the budgetary madness that's sweeping across JPL. So yeah, he's going to be difficult to replace because I know he worked successfully with a number of data producers and was really a key contributor on the day-to-day basis of keeping things running in the PO.DAAC. So we wish Wen-Hao well and thank him for all the contributions that he has made, and he has been to many of these GRIST meetings in the past years. All right, is it the top button I click or the arrow button? It's sensitive and it's going the wrong way. Okay, so I presented this slide last time. I just wanted to kind of reiterate and represent it and just give you the feel again that the PO.DAAC where I work really has a long history, a long lineage, a rich pedigree of supporting oceanographic missions, really since the inception of CSAT is when we first got going. And, you know, this kind of shows the history as we flowed through the various media transformations of going things from like tapes to digital media, and now, of course, I mentioned at the last GRIST meeting, and we are today, we're 100% in the AWS cloud. We don't have any on-premise data stores anymore for satellite products. It's all 100% in the cloud. We do have some on-prem machinery that deal with some kind of like legacy systems, but all the data, in fact, many data producers send their data to us through the cloud, and it remains in the cloud. It never actually gets downloaded anywhere on-prem in any of the NASA systems. So kind of quite an accomplishment. Started in 2018, kind of get ready for SWAT and the Sentinel-6 missions. And, you know, by the time Sentinel-6A rolled around, we were ready, and we were ready for SWAT. And the SWAT data has now been public for the last few months, so it's a quite popular product. But all right, so yeah, I wanted to, you know, I always present some user statistics and usage metrics, and just shows you what we've, the cumulative metrics over the last 12 months or so. So this is kind of overlaps the last science team a little bit, but yeah, on the order of, you know, one of the key metrics is, you know, how many users in the cloud are there right now? And so it's been kind of steady, as I reported last time, kind of in the hundreds. We do see a kind of a big spike sometime in the last couple months. We don't really know what that is about, but I think, you know, even though we've transitioned everything into the cloud, we still have our core user and our user community. So on the average, we have hundreds of users every month. And the other metrics of, the number of distributed files are also consistent to the previous on-prem statistics. And there's a nice seems like there's an upward trending curve right there. Of course, that has a lot to do, of course, with the, this is just GRIS metrics, by the way. This is just GRIS. So this is actually good news that we're seeing some trends in both the distributed volume, the number of clouds, and maybe even the number of users if we count that big little blip there that happened in the last month. Okay, so here's a little fun slide I put together for you guys, and this shows the number of top 20 data sets downloaded since June of 23, but it excludes SWAT. Okay, so full disclosure here, SWAT's like the new sexy kid on the block. a lot of since it's gone public, we've got a lot of users. So we've taken out those SWAT users, and these are just what's left over. And all the arrows that you see on there, these are the number of files. So it's one of these kind of weird metrics, but I think it's a reasonable metrics, as I'll explain. All the little arrows are actually GRIS products. So we see some very popular products on this list right here. Some of the ones that were presented here from NOAA and from JAXA. The top of the list here, actually, those nice new level 3 uncoated products that Ole described are right there on the top. And of course, we like to see the Muir. JPL is responsible for the Muir, and also many of these Modus products you see on this chart here. So this chart, okay, it's number of files, and so it's not fair to compare like one daily level 4, a product that only has one daily file, like a level 4, to like level 2 that has hundreds of files, daily files. But what this shows the activity on the cloud, right? There's stuff going on the cloud, right? People are accessing the data. Really, at the end of the day, we're probably not going to have really files anymore in the cloud. It's just going to be people streaming bytes and using bytes. So we'll have other types of metrics once the users start gravitating and start using the cloud the way it should be used, the way they can start leveraging to do more open and faster science. So it's really about the number of bytes they either stream download locally to their computer, or the number of the bytes that their cloud processing compute programs work on directly when they're natively computing in the cloud. Good. I mentioned that we have this whole cloud recipe tutorial set called the Cookbook, and we're curating some cloud tutorials where users can directly access or run these Jupyter notebooks and do science in the cloud. We actually have a chapter on GRIS, so check that out. There's some nice tutorials on using GRIS data there. And we keep on developing more and adding more. I'll describe some of that stuff, not today, but it's my talk on Thursday and also in my poster session. All right, talking about cloud computing, and I'll talk about this a little bit more on my talk on Thursday, is that we've been developing some very nice cloud-based tutorial recipe kits for doing scientific analysis. And I'm going to be focusing on the lower one. The upper one I presented last time, and we're still working on that. That's to do things like long-term averaging and also pixel-by-pixel comparison. But the other one, we're moving into the area of doing parallel computing to do things like, extracting seasonal trends and doing long time series analysis. And we're using this platform called Coiled, which is a third-party wrapper around DAAC. And we've had a lot of success with this. It's very easy to use. Of course, it'll cost you a little bit of money, but I'll report more detail on this particular activity. We're seeing a lot of positive results and impact. And again, doing things like faster science, cheaper science, more open science using these cloud computing techniques. And we always get asked what does cost money and stuff. So we're carefully keeping tabs on a cost for doing operations like this. So you have something to, you benchmark, say, your emerging computing activities once you move into the cloud, or you're writing proposals on doing cloud data processing, things of that nature. These types of tutorials can help you. All right, since this is June 23 to June 24, so there's some overlap with the last science team meeting in October of last year. But we've released 10 new data sets, and you see the list here. Many of these were mentioned here this morning, including the products from NOAA and some of the other providers from NAVO as well. So the message here is we're still, ingesting more newer products, better products into the community, and some of these actually on this list are already on that nice little slide that I showed that shows the really high usage of GRIS products by number of files. Okay, some other contributions. Sorry, I'm kind of looking over here because like my eyesight is not really good enough to see what's on that screen over there. Wish it was right. But okay, so we're continuing to support the MUIR, the level 4 MUIR, as well as the L2P from both Aquaterra and the SMPP. Those are all running as is. The actual L2P system is now running 100% in the cloud. I think I mentioned that the last GRIS Science team meeting. And for the MUIR, we've just written a proposal. We're trying to seek some funding to bring its machinery, make a science data system in the cloud for this level 4 product. And so we'll see how that goes. We just submitted it. Hopefully we'll get some positive news here in the next month or two. Fortunately, there's not a lot of money in the earth sciences for doing things like technology development, but there is a small focus call. Rosa's called open source science. They're like dedicated, small focused 1-year activities, and that's what we hope to fit in. That's what we submitted to and hope to get funded to. One of the big news I also talk about on my poster is that it's going to be more about the tools and services. So I didn't want to dig too much in the tools in this session. Come to my poster to hear a little bit more about it. But you should know that this nice command line tool that we've written, the PO.DAAC data downloader, which is really the gateway to search for products and find the granules and download them locally to your computers. We've added a subset option for most GRIS data sets, both level 2, level 3, and level 4. So you can just cookie cut and get the information that you need. We're also contributing to various GRIS activities vis-a-vis the GRIS tag team and the climate data assessment framework, intercomparison technical advisory group. You'll hear a little bit more about that from Jorge later. And of course, we continue to support and represent NASA interests in the CEOS SSTVC, and both Jorge and I are making active contributions to this new emerging CEOS Coast VC that we'll hear. We'll have a workshop on Friday where a number of you are going to give some talks, and we're going to get down to the nitty gritty, and there's going to be some remote presentations by Paul DiGiacomo, who's leading this. So yeah, make sure you stop, you're still around on Friday because it's going to be super interesting. We're also on the CEOS ARD Oversight Committee. Okay, I think that was my last slide. I might have one more. Yeah. Yeah, so we're continuing to do a lot of like capacity building and community engagement, and not just in the temperature community either, because SWOT has really given us a springboard to into more interdisciplinary applications. It's actually our gateway into the hydrology community. Of course, that's an interest to this community too, because of lakes and maybe even higher risk down to river temperatures are going to be emerging topic areas in the future. So we built some new services for these SWOT data products, and I'll describe those more in my poster if you want to stop by. One of them is called SWOTler. It's an on-demand raster generation for SWOT products, and the other one is HydroCon. It's for extracting time series data for the SWOT data based on river reaches. So yeah, they're all focused 100% on SWOT, but there's certainly an interdisciplinary component there. And these are things that perhaps could be, in principle, adapted to SST and SST processing at the end of the day. There's new products like the SWOT river discharge products that are going to be important for studying things like coastal SST and SSS variability. So keep apprised of that, and they're going to be tightly linked to this emerging NASA surface biology geology mission, which is our next big earth science mission. So we've launched SWOT, we've launched PACE, and then the next one is going to be SBG, and then the GRACE follow-on mission. I forget what the name of that one is. Not GRACE follow-on anymore, but whatever comes after GRACE follow-on. Yeah, and one of the things we're coming to these workshops too is to engage the various stakeholders in these emerging missions like SIMR, because we do see a need to bring some of that SIMR data to the NASA salinity science team and its community. So yeah, we're interested in networking about SIMR, as well as, of course, the high resolution SST from things like the Trishna and the like Trishna and LSTM and those that are complementary then to the NASA EcoStress and the emerging SPG. So if you are involved with that or want to maybe strategize about how we can work together and do some of this increased capacity building and community engagements, and come talk to us. Me or Jorge are here to engage you on that topic. And now I think that is really my last slide. Yeah, there we go. See us at the poster session. I have a talk on Thursday. and we're around all week. Thank you.
Thanks, Ed. Any questions? Okay, and there's none online. Thanks again.
Thank you.
So now we move to the next talk. It's Dorina giving us the update of ECCC.
Okay. So, hello. First of all, welcome to Montreal. I'm really glad to see you here, and I hope everything will go well during the week. So today, a short update from Environment and Climate Change Canada. Okay, it's not good. Okay, so at Environment and Climate Change Canada, especially at the Canadian Centre for Meteorological and Environmental Prediction, we have only one product as a contribution to GRIST. It's our SST analysis. I think you know this really well. So it's optimal interpolation. We assimilate data from different producers. Mainly, we take our data from PO.DAAC, except for AMSR2 data. We also assimilate in situ data, and we use the ice information from our in-house ice concentration analysis. Here you have two images. The first one is coming from our internal monitoring website. So every day we display SST analysis, not only SST, but also the number of data assimilated and the repartition of this data. And the second one is coming from Environment Canada website, where you can see every day the anomaly from the climatology, and we use our climatology, 20 years climatology. So looking at the last map of anomaly, we were wondering, we are doing better, we are doing good compared with the others. Usually we compare our analysis with the GIMPI product, but GIMPI is not available anymore. So I compare with Ostia, which it looks like it performs better between the L4 products in GRIST. So what I can say is that we are consistent for the last two years, so we don't see any problem. We want to make better, so to have a better performance, but I hope this will come soon. And because I downloaded only Ostia, I wanted also to compare it with the others. So I went to NOAA website to compare our analysis with other products. So here we have the geostationary polar blend from NOAA. We have GAMSA, we have MUR, and compared to Argos, so the analysis is consistent, so it's a good performance, and also compare with the drifting buoys, which are not independent data because we assimilate drifting buoys, drifting and moored buoys, but maybe not exactly the same data. So nothing else about CMCSST. So now I want to present a little bit some work in progress. So these data from NOAA 21 are already available since March last year. And we start doing some tests. The first one was to assimilate this from NOAA 21 together with SWAMI and PP and NOAA 20. And I don't know if, it's not working like this. Oh, sorry, I think I did the same thing as. Okay. Okay. Not yet. The other one, the previous. Okay, I'm gonna go from here. Thank you. Yeah, it's not easy. So in the first, we assimilate NOAA 21 together with the other two VIRS sets. So it's a small, really small improvement when we assimilate this, but is what is expected when you add another similar data set. And the second one was just to see what we get when we replace SWAMI NPP by NOAA 20. And it's good that we did this because we had a problem at the end of May with SWAMI MPP, and maybe we have just to replace SWAMI by NOAA 20. So this will be proposed for implementation this summer. So when we finish this meeting, we are going to work on this to be proposed for implementation. We have to establish just the operational fit for NOAA 21. Another work in progress, we spoke about this a few years ago. Finally, we are able to do some tests to ingest Sentinel SLSTR data from Sentinel 3A and 3B. We tried to work first with near real-time data, but the number of files are huge from two satellites. So we start working with near time critical, so the files that are available the second day, because it's easier to convert them in our internal format. So how we are doing this? So we are using only dual view data. We use this time the SSES provided, and we apply a correction from skin to bulk. And yeah, the results show a small improvement. It's small, but it's an improvement. We run 3 months of summer and 3 months of winter. I notice here just things that we have to look on. There are some biases that looks increased during the summer is in the northern hemisphere for summer 2023, and in the southern hemisphere for the winter. So we have to test more to make at least 1 year of tests before being ready to ingest this data. So now there are others SST-related activities at CMC. So first, now we are at the end of what we call an innovation cycle. So if everything goes well, tomorrow all the system that runs at our center will be declared operational. It took 2 years, but we did this for the last 10 years. We update all the system in the same time. For the SST, we didn't update because a new analysis is coming this fall in operations, and details about this analysis will be presented tomorrow. Sergey is going to give a presentation about this. Other activities, we are involved in different international projects. One of these is SYNOPS project. So about the contribution of different observation, including the SST in our global ice-ocean data assimilation system. This will be presented, it's a poster by Andrew Peterson. And also during the last years, we increased the number of ocean systems. So we have a global ice-ocean prediction system, a regional ice-ocean prediction system covering the 3 oceans around Canada. And also we have coastal oceans from west and east. And Jean-Philippe Paquin will present a poster about the variability in SST using CEOPS East system. So I think this is all. Thank you.
Thank you. Any questions? Okay, thanks again. So now we move to the final presentation of this morning. Online we have Paolo Cipollini giving us the ESA report.
Like I say, this is just a quick report on what we do. Ideally, I would have liked to be there with you. I'll have to do it online. But our main contribution as an agency to the sea surface temperature business, as you know, is by implementing the missions for Copernicus, working on the design and the implementation, on the refinement of the mission requirements. And in this slide, I've got highlighted the main ones that contribute to sea surface temperature, and in some cases to ice surface temperature. So we've got the Sentinel-3, and then its evolution to the next generation optical Sentinel-3 mission, and also the two Copernicus expansions, LSTM and SIMR. So I'll give you a brief update on each one of those and what we are doing and hoping to achieve with those. Sentinel-3, as we've seen, is the workhorse of operational oceanography, and that is, of course, also for sea surface temperature. And we had already presentations, in many of those presentations that was clear, like Andrea and Anne presentation early on. So SLSTR on Sentinel-3A and B provides the current operational capability for the SST for Copernicus. And of course, both A and B are aging, and we are preparing for the launch of Sentinel-3C and D. For Sentinel-3C, as Anne already said in her presentation, we was originally planned to be launched for 2025, but the latest date that we've got in mind is more likely to be mid-2026, at least in the evolution of the Copernicus long-term scenario. And Sentinel-3D should be launched a couple of years afterwards, so around 2028. Now, for the next generation, we are working, as many of you will know, on the preparation of the next generation of the Sentinel-3, which will have a topography mission and an optical mission as separate missions. And on the optical mission, we've got the evolution of OLCI and the SLSTR, so both the color and the temperature sensor. We are now at the stage where we are negotiating the two industrial proposals for phase A and B. So possibly next month, the industrial activity should be starting, but the mission advisory group for Sentinel-3 NGO has been established already since more than 1 year, is holding regular meetings and consolidating the mission requirements. And one of the things that we are particularly looking at is to improve the synergy of the two souls of the mission, the two subsystems, the OLCI and the SLSTR halves, or rather their evolution, A OLCI, A SLSTR. We are talking about something that is going to be launched in 2034 for the first one of 2 satellites, and 2 years later for the second one. Now, this community will be mostly interested in ASLSTR, so that provides the enhanced continuity of observations of SLSTR. And you will be glad to see that the resolution will be improved in the thermal infrared channels. It's currently 1 kilometer, as you know, and will go down to 500 meters. And we are planning to include the 3 additional channels, including a channel at 8.7 micron. This is quite interesting because there are science studies that are looking at the refining the requirements and the impacts of the additional channels, and in particular, the NGS ASLSTR science study has been looking at the impact of this particular channel via simulations. And it turns out that this channel is particularly beneficial, in particular for the daytime retrievals. So when you cannot use the 3.7 channel due to the reflection of the solar energy. As you can see in this slide, the uncertainty from the simulation for net in early daytimes is virtually halved when we add this channel at 8.7. And that's an advantage, a little improvement, but significant also for the dual view daytime retrievals. So we gain a couple of hundreds of a Kelvin. So that's good. We looked also at a possible channel at 4.05 micron, but it looks that the impact is negligible. So I can tell you that with 99% certainty that we will have this 8.7 micron channel on ASLSTR. It will be confirmed pretty soon. The other missions that we are dealing with, of course, are LSTM, high spatial resolution over land and coastal regions, with a resolution of the order of 50 meters and slightly longer revisit time of the order of 4 days, because this swath is sizable, more than 600 kilometers, but still you cannot have everything. And with pretty good radiometric performance, as you can see in this diagram. The launch of this Copernicus expansion mission will happen relatively soon, in 2028. And then, of course, the SIMR, another mission of the Copernicus expansion constellation, a multi-channel microwave radiometer. We expect to be able to retrieve sea surface temperature with a fairly good total standard uncertainty of the order of 0.3 Kelvin and resolution of the order of 15 kilometers. The very good thing about SIMR is that because it's got a very large swath, especially in polar seas, there's highly revisit pattern. It will cover the same point. It will look at the same point up to 8 times per day. Everything is illustrated in this diagram, where you see this. Where you go up in the polar seas, so you see the same point 6 or 7 or 8 revisits per day. So my final slide is this one. You see, we have different missions, as it has been said already in previous presentation. Every time you touch upon, merging data from these different missions, this will be even more crucial for the evolution of Copernicus and of sea surface temperature for Copernicus, because we're going to have high resolution from LSTM with a moderate revisit. Then we're going to have ASLSTR, and we have SLSTR already at the moment, providing the very accurate, very low uncertainty SST that you get from the dual view with a decent revisit time. The goal is to have measurements every 12 hours, of course, day and night. And then you get SIMR, all weather, but of course with lower resolution, but extremely high revisit. So the challenge for the next few months and years will be really to improve the way that we merge those missions and we exploit their synergy. And that's all. Thank you.
Thank you, Paolo. Are there any questions for Paolo? Okay, so I don't see any, and I don't think there are any online either. So thanks again. So I think now before lunch, we've got a little bit of time for any further questions or discussions that anyone would like to bring out before we go to lunch. So just to open the floor to questions and comments, and yeah, please wait for a microphone for those people in the room. If you're online, you can put your question in the chat if you like. And if there are no questions, then it means we get an early lunch, which is also fine.